Hello, this is the presentation of paper ID 94, and being unable to present at the conference center, I am presenting this paper virtually from my location in USA. So our paper topics is smart crowdsourcing based content review system. We call that paper as SCCRS, and it's an approach to improve trustworthiness of online content. So we are three authors. First author is Khadi Gupta, then D. Das Gupta, and me, S. Sen. So let's first come to that motivation why we approach this technique and why we are motivated to go with this research. So we know that there are some content review system. There are some contents which have been reviewed before publication, and some contents being reviewed after publication, and so like after and some contents which get reviewed after someone complains. So the contents which actually get review before publications, they are much in number. You can search any scientific journals, IEEE, SEM, and some news organizations, BBC, CNN, and some like Netflix, ITV, etc. And there are some contents which get review after publication. There are Wikipedia, Stack Overflow, Quora, you can say, and there are also some contents which actually get the review after someone's give complaint, like as Facebook, Twitter, Instagram. So let's see what are the drawbacks of existing review process. First of all, there are some review which are internal reviewer, like as you can say BBC, CNN, and other news organization, and IEEE, SEM, you can say. So but this for small amount of contents, and it's also hard to maintain the diversity among reviewers, and is also costly. So there are another approach to content reviews. Give reviews for content is we like say crowdsourcing, but here there are also some drawbacks. So the reviewers may not go along with the organization policy. They are anonymous, so they might not perform the review as the specifications, as the rules, and they might use their power in abusive way. And there are also possibility that majority wins create opportunity for low quality. Mm, s- so to remove that drawbacks of content review, we are proposing a methodology, and here our purpose is that the reviewer cannot abuse their power, and the and the biasness of the reviewers will also be considered. And another thing is like will be weighted the reviewer based on their quality, and by the weight the reviewers will come first and provide review for further contents, and we also ensure the diversity of the reviewer. So there are related crowdsourcing works, you can say. So for content based, there is NLP and machine learning, which actually uh, take care of the contents, like the which topics the contents are related. So the NLP and machine learning here are used to find out the contents of the like the topics of the contents. And there are also source weight, which is take the decision from weight base, and review base, which is take the decision from majority. So some related works drawbacks, yes, like they are hard to detect sarcasm. So most of the related words, they actually use natural language processing and machine learning to get that topic and the similarity of the contents, and to judge if the contents is related or not, or it is being false news or true news. But every approaches, they're already in published. They don't say anything about the sarcasm. So someone in social media can say something in sarcastic way. It doesn't mean that it will be a false news, or it will be malicious news. So we have to put some human there to detect the sarcasm. So like people like to use trolling online all the time, so it's hard to classify these things. So all the present works which are already established, they didn't say anything with those in this particular field. So our content review approach is like this. So first of all, the context will be classified from contents, and and then from this contents we will find the reviewer list. It's a hierarchical process, and then we'll normalize all the reports of the reviewer, and then we'll check the biasness, if the reviewer is biased to some topics or not. After that, we'll classify the content for publish. So the detailed illustration of our approach is like this. Here's the user. So here's the online content, and the topic will be extracted through NLP algorithm. So so if there any content in the online, through machine learning and NLP will choose the topic. Based on this topic, there will be already some database which have some reviewers calculated based on some topics. If this system is new, then we will put that. So we have to like put some reviewers. So to face the cold start problem, we have to put some reviewers manually before. So here we use multi-objective genetic algorithm to choose the best possible reviewer set for one selected topic, and the reviewer attribute will be come here, and through their availability and familiarity and the quality of the review, the content will be judged as it is will be publishable or not. So here are some process you can see. Is the in the middle we will select the reviewer set, and the reviewer review will be evaluated through machine learning again. And here the database is here to save the topic and related the reviewer set. So this the whole thing is like a sort of backup process, and this one choose the topic, this one choose the reviewer, and this is the reviewer result, and based on this result we use machine learning to select like the binary classification, you can say it will be publishable or not. So let's say how to select a reviewer. So a reviewer will be selected based on their availability, quality, and familiarity. So these are actually the attribute of a reviewer. So is a reviewer is available or not, and the quality is it's a good analytical skill or not, and they are familiar or not with the topic. So there's another thing, why group of multiple reviewers. So why we choose not instead of one reviewers and group of like reviewers. So the main purpose is to ensure the diversity. We want to ensure that all the reviewers is not from one topic, they have some diversity. Just for example, if a contents is like this, it's related to football and medicine. So the reviewers must have to be some side from medical science, also from the sports side. So this is the main purpose to select multiple reviewer here. So let's say how to select the availability of the reviewer. We'll see the daily and recent logging rate, and how the recent and total session rate of the reviewer, and recent and total response rate, in common topics. So it will be also like if a reviewer comfortable with some common topics, they'll be like selected more, and recent response rate in common topics and other network activity also. So let's see now the reviewers quality and familiarity of the subject, how we will choose the quality and familiarity for a reviewer. So the average time took for all the review of the reviewer, average time took for all similar review, and average review process time for a reviewer and failed review rate. So we have also we have to calculate the fail rate also, uh, like for a reviewer, besides the success rate, and there are some review might have undecided and some other attributes also, like the age, sex, and how they are have the degree or related attributes of this topic. Now let's see how we will prepare a reviewer dataset model. First of all, there will be a dataset which is we are calling the training dataset, and in this training data there will be a set of reviewer and some constant list. So we will calculate the average t time for all the data types. So let's say for all the reviewer and we'll choose one reviewer one by one, and we'll calculate the availability of the reviewer, the familiarity of the reviewer, and the quality of the reviewer. And based on these three, we'll calculate AQF value, and then we'll add that reviewer to the data set, because there might have been a lot of reviewers and there are a lot of topics. So based on some topics, we'll choose one reviewer, and then we'll add that reviewer in a data set, and we'll return that data set in the process. So let's see how we calculate the weight. So here's the review rate. We'll calculate based on availability, quality, and familiarity, as I told before. So is the training data, this the server data calculate availability, quality, and familiarity, and then all the accurate value will be stored there, and it will be calculated with system configuration info. Now say how we will generate diverse set of reviewers. Let's say there are a feature topic F, and the sensitivity weight of this feature FSW. We actually used Gini-Simpson index for calculating the diversity for each reviewer. And so after for each reviewer calculating the diversity of each reviewer, we actually put all that information through a multi-objecting genetic algorithm model. So the purpose of using this algorithm is to select a diverse set of reviewer, but the best possible set of reviewer, so that we always can get the best possible set of reviewer for a selected topic. So here generating a reviewer set, I can say after generating a reported content, we will get the context from n number of report, generate a list of concepts. So how we will choose the reviewer set? So we will measure the quality, familiarity, and availability of all the reviewer for every selected topics, and based on how they are providing true positive result, how they are providing true negative result, we will calculate this thing, and then we'll select the reviewer set. Now we'll create a waveform, so where all the contents will present, and the reviewers will give rating to the news from 0 to k. So I think the k might be like the highest value, which is like approved value. We'll provide a threshold here to have the binary classification whether it is publishable or not. So from every reviewer, we will take that value from 0 to k and then give the average. So here the user decision. So individual normalization, we will normalize like every reviewer from 0 to 100 as for example, and then we will take all the reviews from all the reviewers who are related to that the selected topics. Here I also want to include, we also use multi-objective genetic algorithm to select the best possible reviewer set. So from the best possible reviewer set, we will take all the reviews, and with the individual points we will merge all feedback, and then through the machine learning or neural network we will take the decision whether this content is publishable or not. So here the implementation, what we did actually for our research work. So we actually use a steady-state multi-objective genetic algorithm model to select the best possible reviewer set. We used C# to made a demo application, and we picked 9,999 reviewer database which like already have data of availability and familiarity and quality values. Then we normalize all the data from 0 to 1 to be able to run through machine learning algorithm and mathematical things. After that, we calculate the diversity factor here for age, gender, or race for each reviewer set. You can say we use the equation. So now here's the implementation. The user data sample. You can say the first name, last name, age, email. So this is the user data set, and we have all the information of users, where they are from, and there's the implementation. So you can see the set, the familiarity, ability, quality, sex, age, race, diversity, accurate value, and fitness. So as for example, let's select some topic, politics and finance. So this multi-objective genetic algorithm will run through this topic and find out the best possible the reverse set. And so this is the technique we actually want use to find the best possible reverse set to ensure the quality of the review. Here's the empirical result. You can say how the diversity element changes with the multi-objective genetic algorithm process. So at the beginning, this diversity, so you can say sex, age, and race, it was like this, but after some iteration, it gets order, and you can say after 25th iteration, it get more order. So that's how we actually choose the best, fittest possible reviewer set. So here you can say change of the reviewer individual element over GA progress for each set. So for familiarity, ability, and quality, at first in the 0th iteration it was scattered, and after 50 iteration it becomes concise and clustered. So this GA actually ensured the quality, and this is took out the best possible set all the time. So here's the performance analysis for calculating the diversity and accurate value over GA progress. As you can say, the diversity actually becomes saturated after some time. At first it was 0.1, and then it becomes high after 30 iteration. It become 0.25. And here's the accurate value, availability, quality, and familiarity value over time. You can say this is the max accurate value we found after in 10 is close to 30, and the average is close to 6 or 7. You can say here's the change of fitness value over genetic algorithm progress. So it's the best fitness, you can say 0.5 after after 100 iteration, you can see, and the average fitness is 0.3. So now I'm coming to that conclusion. What we actually did, we actually use genetic algorithm in the middle to select the best possible the reviewer set. So as others work, we also used NLP to select the topic from the social media site or online site, and based on the topic we actually use genetic algorithm here to find out the best possible set. I think this part is the unique of our work, and from that best possible set we calculate the attributes of each reviewer, how they are providing the feedback for a content, and based on this feedback we actually use a machine learning algorithm for binary classification, and based on this weight values and all the attributes what the reviewer provided, we actually calculated is it the content publishable or not. So here are three process. First of all, select the content, and the middle one is the selecting the best possible reviewer set based on that content, and the last one is based on the reviewers review and the individual points of the reviewer to select the content, is it publishable or not. So here our proper approach actually have that advantage, we remove the biasness of the reviewer, and we also detect the abuse reviewer, and we also ensure the diversity, and the quality of the reviewers also be ensured because here we use multi-objective genetic algorithm to select the best possible set. Again, in the neural network or machine learning side, which is the last part, we actually evaluated a reviewer's review based on their quality on or based on their profile. So like there is a questions come why a reviewer will provide feedback if they don't have any incentive to provide feedback for the content. So here our future work will include that sort of incentive. We are planning to use a blockchain based reward system. So when a reviewer will provide feedback, we will give some coins or part of a coins to as an incentive to the reviewers, so that they are more interested to provide review for topics in online topics. So I think the throughout this whole process, a content review system can be established easily with trustworthiness, whereas right now the agent system is not trustworthy, and it can also detect the sarcasm and everything. So instead of having bots to select contents and to judge whether it is publishable or not, I think this crowdsourcing approach will provide much positive effect. And it also involves some reviewers who actually wants to give review, wants to like contribute to the world in positive way. So that's all our purpose. I think you guys all understood what we are trying to do, and I think I was also able to provide the information to all. So that's all my presentation here. Thank you. Have a good day.